Now and forever, we bring IT to life.
Good day, and welcome to the BMC Software Connect with Remedy monthly webinar series. Today's conference is being recorded. At this time, I would like to turn the call over to Gregory Keoy. Please go ahead, sir.
Thank you, and thank you everybody for joining for this month's Connect with Remedy webinar series. Today we're going to talk about BMC Atrium CMDB best practices. And we have Stephen Earl, our lead product manager for CMDB, that'll take us through that content. Stephen?
Thank you very much, Greg. So good morning, good afternoon, good evening, wherever you may be in the world. My name is Stephen Earl. I'm the lead product manager for Atrium CMDB here at BMC Software. I've been with BMC since March last year, and I'm happy to walk you through our CMDB best practices webinar today. I hope you find the information contained in it useful, valuable, informative. If you have any questions, please feel free to ask them in the Q&A section of the WebEx, where my co-panelists will try to answer them as we go along, and if there are any unanswered ones, we'll try to address them at the end of the webinar. So, there are many challenges to IT departments and businesses in general today, and I'm going to go through a couple of ones that we see related to CMDB in the next few slides. The first one is that IT and businesses are dealing with ever more complex infrastructures, services, application models, much more dynamic with the rise of virtualization. Sometimes you don't even know actually where a host is at any particular given point in time without looking at a hypervisor, for instance, to see which resources have been allocated to a particular host for and workload. So today you have to cope with much more complex environments than back in the day, as it were, where we had servers on racks and servers did a job and you could physically go and touch them all the time. Today we don't have that solidity. Much more complex, much more dynamic. We have private and public clouds, so you don't even always own your own infrastructure. And with that ever more dynamic infrastructure and data centers paradigm, we have an accelerating pace of change in digital services. So what that means is people are now making changes hourly to infrastructure or applications rather than the good old days of every Thursday and every Tuesday between 2 a.m. and 4 p.m. in the afternoon. You would get a change window where you could basically do what you wanted, and you could even have downtime. In today's world, we have zero downtime. We have constant agile deployment. We have the DevOps movement. We have just a constant appetite for things to be updated and changed effectively on the fly. You look at the rate of change that Google implement things like Gmail, etc. They will literally implement hourly, if not every 15 minutes, but the changes aren't always visible to everybody, but they're making changes to the production environment at an almost constant pace. And number three, with this constantly changing, ever dynamic world of infrastructure and applications and services, people still want to have accurate data on which to base business decisions and technical decisions. And this data has to be very high quality, it has to be readily available, and has to be there for decision makers to consume as and when they need. So the question is, how do you get a handle on all this, and where do you start when you have the Atrium CMDB? So at BMC, we believe that consumers are king when it comes to the CMDB. It's very easy for the CMDB to become a large data warehouse that holds everything about everything, and then for administrators, configuration managers, and other users of the CMDB, it becomes unwieldy, it becomes bloated, it becomes hard to manipulate, it becomes hard to find the information you need to support your business and IT operations. So our viewpoint is that we take a consumer's view when it comes to CMDB and the data that's stored there. And in order to have an effective CMDB, we believe that the first conversation that needs to actually be had is with people who will consume the data in the business and within the IT operations realm. What data are we going to store? How is it going to be structured? What actual purpose is it going to have? And then what you do is you go to the providers of that information and request the data that you want. So it's very, very easy for providers to come to the table and say, look at all this great information we've got for you, and then just throw it at you, expecting you to handle it, have somewhere to put it, have somewhere to store it, when in actual fact what you're actually interested in is the data that your business needs to drive its decision making and support its processes. And you need to be able to sift through all that provider data and know what's interesting, so you know that you want to hold it and you know that you want to store it for some specific purpose. So what data should be stored? Well, a few guidelines. Data stored should have a purpose. It should have a consumer. The CMDB holds configuration data, and it does not, and you should not store transient data. Now, what do I mean by configuration versus transient? I'll give you an example. A server has a 4 terabyte hard drive in it. Well, in the CMDB, we would expect you to hold the server, the operating system on the server, software installed on the server, its network card, etc., and this 4 terabyte hard drive. What we wouldn't expect to be held in the CMDB is that the hard drive has 500 gig used and 3.5 terabytes free. That really is transient operational data, which doesn't lend itself to being configuration data, because the minute you've hit save, it's now out of date. So really that operational usage kind of base data is not the kind of data we would expect to see in the CMDB. But the structural server, network card, the IP address configuration, and the hard drive we would expect to see in the CMDB. So the slide on the screen now is there to illustrate that there are many, many sources of data, and there are many consumers of data. So good examples of sources of data would be ADDM, BMC client management, spreadsheets. We all know we have lots of spreadsheets. Other management systems such as facilities management or building management systems, or other things, other systems that manage other systems that we can't directly talk to or discover. People are a discovery source. They are a provider of information to the CMDB, and other trusted sources. So, for instance, Exchange is usually a good source for people information. Your HR system, your SAP system, for instance. And then we have all the consumers. For instance, your ITIL processes, incident management, change management, asset management, self-service systems, and of course provisioning systems and other consumers of data. Now, the graphic in the center of this slide is this way on purpose. In what we're illustrating is, in the CMDB we can take multiple data sources, and the purpose of the data processes and the engines and the technology of the CMDB is to take those multiple data sources and turn them into what we call a production data set, which I'll talk about later. So you can have that single pane of glass on your IT infrastructure, your services, your applications, etc. So I'm going to talk about data sets. We've done a little bit of talking about providers, and that leads nicely into talking about data sets. So data sets in the BMC Atrium CMDB, we have two kinds of data sets. We have standard data sets and we have overlay data sets. A standard data set is a self-contained store of CIs and their relationships. So it's the data that has come from the providers and is ready to go through our data processing processes. So normalization, identification, and merging by the reconciliation engine. They are not overlay data sets ever. Standard data sets are usually persistent and are there for the duration to take these data feeds in. Overlay data sets contain changes. So for those of you who aren't as old as I, overlay data sets work very, very much like an overhead projector at school. You have a base standard data set, and an overlay sits above the standard data set and contains the changes that you want to make or have made. For instance, you may have two CIs that you want to manually create a relationship with. The overlay data set would only contain the relationship. It does not need to contain the two CIs you're relating because they already exist in the standard data set below. So what happens when the CMDB engines read the data is they read the relationship and they also read the layer below. So it works just like an overhead projector where you have an acetate sheet and you place more sheets on top of it in order to build up the whole picture. That is how overlay data sets are used. So as I just said, it contains only the changes and it reads everything through from the underlying information. So there is a special data set. The special data set is what we call the production data set, or the one data set. It's a standard data set. It is persistent. It is not transient. It is there for a meaningful purpose. It is derived in that it is not written to directly by people or written to by a data set or a data source. And it is the primary source for consumers of the CMDB. So it is the thing that asset management reads from. It is the place that the incident management team get their data from. It is the place that other systems would look for their data if they were trying to consume data from the CMDB. All the other data sets, normalization, reconciliation, all the data quality and data integrity functionality of the CMDB exists to create this production data set. So, we have several best practices around data sets. I will quickly run through them on this slide and we'll talk about each of them in detail on following slides. So, the first best practice is never ever write directly to the one production data set. The second one is leverage delta data loads. Don't purge discovery source data sets. And that's very important. There's a difference between purging and deleting from. Discovery source dataset alignment. Actively manage source dataset exceptions. And leverage the power of federation. And if you haven't run into or used federation yet, I'll explain a little bit about it later on. So, the first one, never ever write directly to the one production dataset. So common reasons that we get for violating this best practice is that it's faster if you just write directly into production. You don't need to wait for normalization and reconciliation and the identifying jobs and the merge jobs to happen. Your data's just right there for you. Well, yeah, there's reasons that that's bad. For instance, your data integrity rules will be bypassed. Your data normalization will be bypassed. It's difficult to tell what really happened to get that data into the production data set. You don't have the provenance, you aren't able to trace exactly what happened. And also, usually humans like to do this directly entering into the production data set, and sometimes the data quality can definitely be lower than we would want. The CI only needs to exist there. It doesn't exist anywhere else. I only have it in one discovery source or one other place, so I can just put it straight in production. There is still value to running it through the reconciliation rules for identify and merge. You may not know that another tool does actually discover the stuff that you're importing, and there may well be valuable data that you are now not taking advantage of. But placing it into a discovery data set and running it through the data quality and data integrity engines of normalization and reconciliation it doesn't add that much time. It will give you the data to production in a clean way that's adhering to all the policies that all the other data sets adhere to, and it will give you control and traceability that otherwise you wouldn't have. Leveraging Delta data loads. So common reasons are given. We don't know what's changed, and you can. So yes, the problem with violating this best practice is that A, you increase the time it takes for the data to come into the CMDB, flow through and get to the production data set. If you're reloading millions of rows every night when the data hasn't actually changed, then you are effectively expending energy and effort loading data that you already have and processing data that you don't actually need to process. So it's very time consuming to not use Delta data loads. You're introducing larger load onto the system. Again, that huge bulk of data coming through that's unnecessary. And if you do have a large volume of data, no matter how big your database, no matter how powerful your servers, no matter how much bandwidth you have between them, the answer to deal with volume is to look at the volume, not just build a bigger, better one. So what we look at, we provided functionality to help, but for instance, discovery sources should be able to interpret what has changed in them and only send you the difference. If your data source cannot do that, then if you're integrating with Atrium Integrator, we have a function in Atrium Integrator which will allow you to generate checksums on the data as it comes in. If it's new, it will get a checksum generated and sent off to the CMDB through the integration. If data comes along that where the checksums match, then the data will be thrown away by Atrium Integrator because it doesn't need to be processed because the checksums match. And if you get data where the checksum is different, then of course it's deemed to have changed and carries on through to the CMDB. So we have provided you a utility to help with this if your discovery source can't do it. The functionality is explained in the documentation on docs.bmc.com. And we find it very, very valuable. We find it definitely helps customers once they implement using the checksum functionality. There is a small overhead in Atrium Integrator generating the checksum as it analyzes the data, but the value of that is far outweighed by the benefit of using the checksum to get Delta data. The next one, don't purge discovery data source sets. So, common reasons, reduce database footprint, cleans out all the bad records, and why not? We're going to tell you why not. So, the issues that come out of purging is that you lose all the history, you lose all the provenance, you lose all the data as it was when it started its journey through the CMDB. So it's much harder to trace data problems and track them down and resolve them. As we said, the production data set is a purely derived data set. As such, if you delete your source data by purging, then should you need to reconstruct the production data set, the way you would reconstruct that as it's derived is you would rerun your reconciliation, identity, and merge jobs, and that would regenerate your production data set for you. But if you've purged all your source data sets, that data is now gone. So in order to recreate production, you would have to make sure you've re-imported all your source data sets and then rerun your jobs, but you would lose the history and provenance again of what was that data like before. You also risk duplicates because when you purge your data sets and the identified jobs in the reconciliation run, etc., you may end up finding duplicates because you no longer have that historic data volume. And as we said, it's difficult to reapply and rerun rules to data that's no longer there. Discovery source alignment. So this practice is commonly violated as people see having multiple data sets as being complex and complicated and hard to manage. There is actually, the Atrium CMDB has no limit to the number of data sets you can have, and our feedback from customers that we worked with and the structure of the application is that have as many data sets as you need. You should have a data set at least for every source. You may have intermediate data sets. So for instance, say you've got 9 data sources, you may take them in chunks of 3 to reconcile together. So then you take the next 3 down and then turn them into production, rather than taking it to the state of just taking all 9 straight to production. Having more tiers of reconciliation and data sets can actually make things simpler when troubleshooting data problems later. Although it looks more complex up front, the value it can give you for detecting data issues and following the data through how it came in to how it got to production can actually be easier if you have more intermediate steps that you can anchor to when you're doing your investigation. Actively manage your discovery, data source exceptions. This is one of the more contentious best practices that we have. So there are many reasons why people violate this best practice. One of them is I don't have the time to track it down, I'll just fix it in production. The other one is it's not my job and we don't know how. So what we're talking about here is that when problem data enters the CMDB, and by problem data it could violate rules, it could violate, it may not be able to be normalized, it may not be able to be identified or merged for whatever reason, or when you get to production it just doesn't look right. Because production is derived and the CMDB does not actually own the data that the data sets are providing, this is a very important point, it does not own the data, it's just taking it in and processing it based on the rules. It's very important that when you trace it back that the data gets fixed in the source of the data, because the source owns the data that it's sending over. The CMDB doesn't take it, basically is a guardian of it, but doesn't own it. So if you go and fix it in production today, and then your import job runs tonight, and the next day you come in, oh, the data's back to how it was, broken, because your change has been overwritten by the new data source update that's come in. What needs to happen is the data source needs to fix it, because only then will it flow from beginning through to the end, fully end-to-end correctly. So it's very important that the time and effort is taken to identify where your trouble data lives, and that the owners of that data source are made aware of effectively their responsibility to make sure the data they send you is correct and as it should be from that data source. Sorry. So also, if you don't take that effort and time and trouble, you end up not realizing that your data sources are providing incorrect information in the first place, because people will go along and fix it and kind of the problem gets covered up because people go and edit it and fix it, and really it should be fixed at the source so that it's fixed universally rather than just for that particular purpose. Leveraging federation. So the reason people don't leverage, or some of the reasons we hear that people don't leverage federation is, I just need one place. So this is the data warehouse syndrome that I was mentioning at the top of the presentation. People view the CMDB as a single data warehouse that holds all data about everything. I have a consuming app and I just need a couple more attributes. So I just need one more piece of information and then it makes it so much easier for me. The danger here is that the CMDB starts to become polluted with this non-configuration data. There's no guarantee that that data will continue to be maintained. There's no guarantee that the data source that you think you're getting it from will continue to provide it. So unless it's under the right conditions, then that data may well become stale. This also falls into the CMDB as a data warehouse situation. Having all data in one place, so if you start into the data warehouse world, it doesn't scale in the effectively the RDBMS situation. Having all your information in one place, things will slow down, the volume will get large, and you won't get the performance that you need and the performance you expect out of an operational tool. As we mentioned with the hard disk drive and the server earlier, the transient operational data is stale the second you save it. So there is no point holding it here. And the metadata surrounding data is owned by the system of record. So you should be able, the system of record is where you should be obtaining it from when you need to use it. So now a little bit about data. So as I've said all along, you cannot or should not fix the data in the production dataset. It will get overwritten by discovery. It will get overwritten by other things later. So you will become incredibly frustrated trying to manage data corrections within the production dataset. You should review data regularly with your consumers to make sure, A, it's still being consumed, so there is still a need for it to be held, and that your supporting processes are aware of the data that you hold if you are holding stuff that they would be interested in. Maybe another consumer has some data there that they're not aware is there and it would actually add value in a system. Also, keep your normalization, identity and merge jobs or reconciliation as simple as you can. So this is where the multiple data sets come in. Although it looks complex, for debugging and troubleshooting, it's actually easier if you have a tree-like structure for managing your data to trace it back. So the simpler you keep these rules, the easier it will be to trace what happened to them as the data flow through. So these best practices, we started documenting them towards the tail end of last year. We had a discussion at our Engage 2014 conference regarding them, and we have started publishing them on docs.bmc.com. They are available. Just search for Atrium CMDB best practices on docs.bmc.com and you will find them there. We're very interested in feedback from you, our customers, partners, on what more best practices you feel would help assist you be successful with CMDB deployments, what more you would like to see from us, if there are any particular topics that you feel we could enrich further with this. We have people who are looking at how we enhance this and how we carry it forward and how we expand it and how we can help you be more successful. And that's all directly from me for the presentation. I'll hand it over back to Greg. Greg?
Hi, Steve. Greg is actually on another call. This is Steve.
Oh.
Hello?
Hello?
Yes, hi. Can you hear me, Stephen?
Yeah.
Okay, very good. We do have a few questions in the Q&A sections that weren't answered, so I'd like to run them by you if you don't mind. Let's see. The first one is, what are the steps to get a new data set if purge was used?
What are the steps to repopulate the data set?
I believe
I'm
so.
guessing. So effectively, yeah, if you've purged your data set, the only way is to rerun your import job from your appropriate data sources. Once it's purged, it is gone. So you would effectively be repopulating from scratch at that point.
Okay. The next question is, will overlay dataset hold changes at attribute level? And can we use it like an audit feature?
So they're not really used for auditing. That's not an intended purpose. They hold at attribute level. What they're usually used for, from a purpose perspective, is they're used for trying to look at how things will be after a change is completed, for instance. Or if you're doing service model building, then you may have overlays for building service models ahead of time, and then you promote them to production when they're completed, similar to how the asset sandbox works. But the asset sandbox isn't an overlay yet, but will be. So they're very good for future forward-looking sandbox type environments.
Stephen?
Yep.
Stephen, this is Doug Mueller. I just want to follow up on this question for a minute.
By all means.
For the answer is both yes and no. It is not an audit feature. However, there is a feature in the reconciliation engine that when you're setting up precedents and when you're setting up the way, when you're picking which data set wins, there's a feature called ignore null values or read through null values. And what that means is that if you have a data set, you say, hey, you win, but if the value is null for a given attribute, it ignores that data set and goes on to the next data set in order. So what you can do is you can have an overlay data set, especially a manual entry data set, that you only enter the values you want to override. It's not an audit, but you only enter the values you want to override and null for everything else. And then even if precedent says you should win, by setting that flag, it will ignore that and go on to the other data set. So it allows you to override just some attributes, but not others. Hopefully that makes sense. So it's not an audit, but it does allow you to selectively specify attributes and selectively override using that feature of the reconciliation engine.
Thanks, Doug.
Okay, Stephen, I've got two more questions here. If there were no auto-discovery tools in place for populating asset management and CIs to provide normalization, what pitfalls should I be aware of besides time for manual reconciliation and need to relate incident, problem, and change?
That's a good one. So what we're talking about here is a situation where basically you're working from spreadsheets or manual direct entry. So you should still make use of data sets for your various inputs for sure, because although you're not auto-discovering, you still want to apply normalization and reconciliation rules to make sure that your various manual edits are being treated appropriately and coming up with rules. The rules are no different than if you're using automated data sets. It's just the way the data is getting in there. So the thing I would mainly caution is be much more cautious around your data and your data quality if you truly are doing manual input all the way. I don't know if Doug or Darius may have some considerations around manual.
Manual updates are always something that's going to occur within a CMDB, but the key to success with a CMDB is to be religious about using data sets. Absolutely religious. And what that means is that you're going to end up with a situation where every single data source, every single input is going to come into its own data set. So every automated discovery goes in its own data set. Every source of manual input. So if you have people coming in from a spreadsheet, that goes into a data set. If you have people typing data in, that goes into a separate data set. If you have people doing it for service modeling, that goes into a separate data set. Keep the data from the different sources or the different purposes separate. Now you have the ability to use reconciliation to merge it together. So fine, load the data as needed from the different sources. Treat those as the kind of repository, the receiving point. A data set is the receiver of that data coming from the outside, manual or automated, and then you use normalization and reconciliation. And why that's so critical is even manual entry may not be the winning precedent. You may specify that, I'm sorry, the automated tool that comes in and says I have 4 CPUs there on that particular machine, that data is going to win over, no, I don't care what anybody says manually, I'm going to make that the winner because that's what reality is. And so just because someone typed it in, your still rules may not say it's the winner. So always come through that flow. Whether it's a spreadsheet loading and you typed it in, that's still a form of manual entry. You could treat the discovery source as the spreadsheet, but just come into the data sets and reconcile and follow the rules from there.
All right, very good. All right, Stephen, our last question here is it possible to have the discovery of BMC computer system in one data set, for example, hardware data set, but have the software in another data set, for example, software data set? How would you set up the relationship between the two data sets?
So that's definitely possible to do. So as you may well have multiple discovery sources doing that. The question is if we're looking to try and automatically generate the relationships between the two data sets, or is this or is there data in those to identify the things that are related already? I think that would be the key. Otherwise, I believe you'd be needing to build those relationships manually.
Actually, Stephen, there's two ways to handle this. So the idea is, the assumption, let's go back to what your comment was, Stephen. One is you need to have some way of determining if these things are related. And so if you don't, then of course that's all manual. But let's assume they did have that ability. And so when you discover the software, you did know what machine it's on, right? Say you did that. There's two ways to handle that. Option number one is you go ahead and bring all the hardware into one data set, and you treat that as the master source of hardware. You bring in the software to the software data set, and as you're creating the software, you also create hardware entries, because you need to create those so you can create relationships to it. And then when you use reconciliation identity, you'd match the hardware entry in the software data set to the hardware entry in the hardware data set, and then you'd make sure the precedent says the hardware data set wins for all software, so that you're only having the entry, the hardware item in the software data set to allow it to have the anchor to the endpoint of the software, right? So that's one mechanism, and probably that's the best mechanism for kind of an automated discovery, because you do know in the software discovery, you do know enough about the hardware to know what its name is. For example, I'm on this machine by serial number, name, or whatever, and you can use identity to match those two. You don't know the gory details of the hardware. That comes in the hardware data set, but you know just enough to be able to create the instance in that software data set, and then use reconciliation identity to match that to the hardware item, and then use a precedent. Hardware items win from hardware, software items win from software, and the relationships come from the software data set. And so that you can use that as a general model. Whenever you have data coming from multiple places and you want the relationship, usually the piece that has the related data, like the hardware doesn't know about the software, but software knows enough about the hardware, I know where I'm running, right? And so it can create at least a shell entry, an entry enough to have an identity, although it doesn't have the gory details. And that's one option, probably the most common option in a scenario like this. The other option, which is less used in an automated case but heavily used in a manual case, is you make the software data set a overlay data set, a permanent overlay that is there forever. And so what you do is you discover your hardware, you reconcile that you reconcile that to production, you're good. As you're discovering software, because the software entries go into this overlay data set, because it's an overlay and you're overlaying the production data set, you actually can see the hardware because the hardware is there. So because you're reading through, and you can make your relationships just fine. I mean, I guess you could in this case just overlay the hardware data set as well. If all the hardware is going to be in the hardware data set, you can overlay the hardware data set, although generally you overlay production, but it's your choice. But the key to this is it's a permanent overlay, because the hardware bleeds through, you can always step to relationships because the relationship now has the endpoint. The endpoint is the hardware that's being read through, the software that's in the overlay data set. So it's two ways to do this. Either way works, and this is assuming, and again, it's a pattern. It's not just for software, it's a pattern that you can rely on. Hopefully that makes sense to everyone. It's a quick answer to summarize things, but hopefully that makes sense.
Thank you, Doug.
Great. Thank you very much. That's it for the Q&A section, Stephen. I want to thank everybody for joining today's Connect with Remedy webinar. Today's recording will be posted in the communities within a week, and the Q&A questions and answers will be posted as well. Thank you very much for attending. Back to you, operator.
That concludes today's conference. Thank you for your participation.
Now and forever, we bring IT to life.